in physics. Alright, question number 1. A footballer throws a football at 45 degrees above the horizontal at a velocity of 3.5 meters per second. What is the horizontal component of the velocity? So in this case, going to say velocity is given as, okay, in this case we're talking about the x component is given by velocity cos theta. Now the x component is going to be the velocity is 3.5, and then cos the angle theta here is 45. So 3.5 cos 35 is going to be 2.5. So that is it. That's the horizontal component or the x component. Which of the following physical quantities is not a vector? We've got acceleration, current, momentum. Now acceleration we know is a vector. Current describes the flow of electricity in an electric current, circuit. So electricity always flows from the positive terminal to the negative, so it shows direction. So we qualify it to be a vector. Well, some books will say current is not a vector, and the reason is it doesn't follow the addition of vectors. You know that if you have got vectors which are going, let's say, in this direction, for you to be able to get these vectors, you are going to get their hypotenuse. That will give you their sum. All right, you are going to add them head on, so you might find the hypotenuse as their sum. In this case, if you get to add these vectors, their resultant is going to be in this direction. Now when it comes to current, you have got this one and this one. You are just going to add. If this is 2, there is 2 volts there, there is 2 amps there is 3 amps here. You're just going to add 3 plus 2. That gives you 5. So it doesn't follow the way we get to add vectors. That is why some books disqualify current as a vector following that property. Otherwise, because it has got both magnitude and direction, you're going to say it is a vector. Momentum is a product of mass and velocity, so we are multiplying a vector quantity and a scalar. So the result is going to be a vector. That's why momentum is a vector, but speed we know is not a vector. So that's the answer here. Which of the following is equal to a unit of pressure, which is a Pascal? Now we know that pressure is given by force divided by area, and force is given in newtons. Area is given in meters squared. So this is equal to a Pascal. Now since this value is not there, we can go on. We also know that this force is given by mass times gravity, and then in the denominator we've got m squared. Instead of me saying mass times gravity, let me say mass times acceleration, because gravity is simple acceleration. Before I even put m squared, let me put area there. So we know the unit for mass is a kg. The unit for acceleration is meter per second squared. And then in the denominator we've got area, which is given in meters squared. So 1 meter will cancel with 1 meter in the denominator. So we're going to remain with kg. Since the meter is in the denominator, so we're going to put per. And then this second squared is also in the denominator because we can see this line. So that is going to be kg meter per second squared, which is C. If an unbalanced force of 19 newtons acts on a mass of 39.2 kg, the acceleration produced is, now we know that force is equal to mass multiplied by acceleration. We have got a force of 19 newtons and then a mass of 39.2. So to find the acceleration, divide both sides by 39.2, and that will give us about 0.48. Now 0.48 we can write it approximately as 0.5, so that is it. A vector quantity defined as a change in velocity of a particle during a time interval divided by the time is. Now we're talking of the change in velocity divided by the time. We know that change in velocity over time is acceleration. Now here we're talking about time interval. Whenever you're referring to time interval, you are going to find average acceleration. But if it is at a certain point, okay, at a certain point, that will be called instantaneous acceleration, because it's an interval, that will be average acceleration. A stone is dropped from the top of a 100-meter cliff. The velocity with which it hits the ground is, now it is from 100 meters cliff. How can you find the velocity with which it hits the ground? So you know that v squared is equal to u squared plus 2gh. This will give us v squared. So since it is dropped, you didn't throw it, the initial velocity is 0. And then plus 2, it is dropping, g is positive 9.8. It is coming from a height of 100 meters. So to be able to remain with v, we are going to square root both sides. We square root this side, also square root this side. And that is going to give us 44.27, which is approximately 44.3. So that is it. Mass is a scalar quantity and is the same as weight. Now we know that weight is mass times gravity. Varies depending on the place. We know it is only weight which depends on the place, otherwise mass is constant. Depends on the size of the body. Not really. Is constant. Yes, we know mass is constant. Okay, mass is constant. So mass doesn't depend on the size of the body really. Okay, that is because you can have a very small object which is 1 kg, and you can have a very big object which is also 1 kg. A measure of inertia is termed as momentum, really not, weight, mass, force. So you need to know that mass is the measure of inertia. Inertia is the tendency of an object to resist change. So how massive something is determines how much change is going to resist change in motion. Which of the following is a vector quantity? Mass, current, speed. As we said, we saw that current is a vector. Now at the same time, current is a scalar, which is a vector. So current is a scalar because it doesn't follow the properties that we use when we are adding vectors. Otherwise, it has got both magnitude and direction. That is why it is a vector. A 20 Newton force applied on a 2 kg mass which is in contact with an 8 kg mass pushes the two masses horizontally on a frictionless surface. What is the magnitude of the force that the 8 kg mass exerts on the 2 kg mass? So this one is a 2 kg mass and we've got 8 kg mass. You've applied a force on a 2 kg mass. So firstly, we should be able to find the acceleration at which these two masses are going to be able to move. The force that we are applying is 20. Since the masses are in contact, we are going to add them. 2 plus 8, that will give us 10. So the net acceleration at which they will move is 2 meters per second squared. So to be able to see the magnitude of the force that the 8 kg mass exerts on the 2 kg mass, this one exerting on this one, we need first to find the force that the 2 kg mass is exerting on the 8 kg mass, because we are applying a force on the 2 kg object. And using the same equation, force is equal to mass times acceleration. Now we're talking about the force that the 2 kg mass is exerting. So that will be equal to mass. We're going to on what mass are we exerting a force? So we're exerting a force on the 8 kg mass. So the 2 kg mass is exerting a force on the 8 kg mass, and then multiply by the acceleration, which is 2. So this is going to give us 16. So this is the force that the 2 kg mass is exerting on the 8 kg mass. And it is going to be the same force that the 8 kg mass is going to exert on the 2 kg mass, but they are going to be opposite in direction. The reason as to why they're opposite in direction is according to Newton's third law of motion. So if the force was applied in this direction, the forces that each object would exert on each other would be, so the 8 kg mass would be exerting a force on the 2 kg mass. So we would have found that by putting a 2 here, the acceleration will still be the same. So that would have given us 4 newtons. And this is the force that a 2 kg mass would have been exerting on the 8 kg mass if we applied the force in this direction. A hunter on a hill aims at the head of a monkey that hangs on a branch of a tree. The hunter and the monkey are on the same height from the ground. Just the instant he fires, the monkey drops the bullet. Alright, so what you have is, let's say the hunter is on top here and he gets to fire on a tree where the monkey is, and they are the same height. Let's say the monkey is at this point. So him aims to fire straight like that on the head. Now immediately he fires, the monkey drops. What is going to happen is when he gets to fire, because there is no any component in the y direction for the velocity of the bullet that he has fired, there's only the x or the horizontal component. The velocity, because of gravity of the bullet, is going to be, the bullet is going to be put down like that. So by the time the monkey drops to this height, the bullet would have also reached that height. So they are going to be on the same position, and hence the bullet is going to hit the head of the monkey. All right. So that is because the bullet was thrown and there is no component in the y direction. So the initial velocity of the bullet is 0 in the y direction. Same, the initial velocity of the monkey is 0 in the y direction because it just dropped. Okay. The next question, a man standing on top of a building fires a bullet horizontally and at the same time drops another one. The time taken for the bullets to hit the ground is, you throw something in this direction. At the same time, you also drop something down. What will be the time? Which one is going to reach first? Well, both are going to reach down first. It's the same scenario as this one. That is because you don't have any component in the y direction for this one. So despite it being thrown in the forward direction, it is going to have the same acceleration down. It's just that it's going to reach down on a much further distance, but they're going to reach at the same time because they're subjected to the same acceleration. All right, so the time to reach the ground is going to be same for both. A uniform acceleration results when velocity remains constant, varies linearly with time, depends inversely on time. Now, when velocity remains constant, acceleration is equal to 0. When velocity varies linearly with time, what we're going to see is something like this, a line like this if you have a velocity time graph. So this will give you a constant acceleration. Now it depends inversely on the time that will go like this. This is the deceleration. It's a quadratic function of time. A quadratic function of time meaning it is something like this or something like this. So that will not give us a constant, a uniform acceleration. It will be a changing acceleration. So the answer is B. A projectile that is fired will have the maximum horizontal range if the angle above the horizontal it is thrown is. So maximum horizontal range happens when the angle of the throw is 45 degrees.